Hey everyone, so welcome back. In this video, I want to expand on the idea that we talked about in the previous one, a small technique where you replace a function with another function. So let's see how that works out. Now, let's say I have a function, right, 9x plus 12y. I can replace this with another function, or I can say it's equivalent to another function if I can factor out something that they both have in common. So this can be rewritten as 3x plus 4y. And then I can say that this is equivalent to another function, so I label it g, signaling that it's a different function. And in this case, it's going to be 3x plus 4y. Now, I'm saying that these have equivalent value. I'm saying that f of 9x plus 12y is equivalent to another function. That means you can manipulate the original function and factor out a value, and you should get a new function that if you evaluate it at 3x plus 4y, you get the same value as f. I'm going to use some concrete examples. A little bit easier, not using two variables, just one. So here's one example. All right, so let's say I have the function f 4x plus 10. Right, so this can be any function evaluated at 4x plus 10. Now, I can factor out a 2. So that'll be 2, then 2x plus 5. Now, what this is saying is that I can find a new function g. This is equivalent to some other function g, 2x plus 5. Remember, this can be any function, so you can pick any function that you want. Let's say we go with e to the x, right? So if f of x equals e to the x, right? It can be any function. We're going to go with f of x equal to e to the x. Then f of 4x plus 10 is going to equal e to the 4x plus 10. Then f of 4x plus 10 is going to equal e to the 2x plus 5. So we have found our new function, our function g. Notice that this has been factored. So now we can say that there exists a function g of x, and that function is going to be e to the x. So now let's go back and check if this will give us the same solution. Remember, we are saying that any function you take, 4x plus 10, you can manipulate it and get a new function g, but evaluate it at 2x plus 5, and you should get the same result. So let's see if that is true. So if f of x equals e to the x, then right, this has already been evaluated for us. We're going to get the following. We're going to get e to the 4x plus 10. And we said, then g, our function g is going to be e to the x. So let's try that out. So we get e. If we want to evaluate 2x plus 5, so that we get e 2, and then set 2x plus 5. So then we would get e to the 4x plus 10 equals e to the 4x plus 10. So it is true that if you have a function f, you can factor out 2, and you will get the same result as if you have another function g at 2x plus 5. And how do you find that function g? You just got to manipulate function f. So this is a very useful technique because that means you can replace this or make this substitution in an equation, and we'll see those substitutions later on, especially with auxiliary conditions, which is coming up. So let's do another concrete example. It's a little more complicated, so you can see how it kind of works out. So let's say it's always for negative numbers. So let's say I have f of negative 3x plus 15. Right, you can factor out a negative 3. So that's going to be f of negative 3. It's going to be x minus 5. So now I can say that my function f of 3x plus 15 is also equal to some other function g of x minus 5. Like I can replace that with that all day, every day. Again, you could just, if you just know this part, that's fine. But again, I myself as a student wanted to know, like, does it actually work and how does it work? So you have to like come up with your own example. So we're saying that let f be any function. So we can say, okay, then let's say, now say f is equal to x squared plus x plus 1. So then f of negative 3x plus 15 is going to be negative 3x plus 15 squared plus negative 3x plus 15 plus 1. We can factor out a 3. So that's going to give us negative 3x plus 5, I mean minus 5, plus negative 3x minus 5 plus 1. And we would end up with, again, this is gets distributed, so you get 9x minus 5 squared minus 3x minus 5 plus 1. So now we've gone and actually found our g of x. So if f of x is this this function, then our g of x would be, then our g function would be 9x squared minus 3x plus 1. All right. So again, so you can always make the substitution. You can factor out a common factor and then just replace with another function g. So this is the same as this. So any function evaluated at 3x plus 5 will give you the same result as any other, as the function g minus 5. It's like simplifying. You can think of it as simplifying. So let's see. Will that give us the same result? You know, using our concrete example. Again, this should work for any function, but using our concrete example, no, this might take a little more space. So if f of x is equal to x squared plus x plus 1, and we want to evaluate 3x minus 5, we would get, again, this expression that we got earlier. So we would end up with minus 3x plus 15 squared plus minus 3x plus 15 plus 1. But is that equal to some other function g evaluated at x minus 5? Well, if that's equal to that, then we can manipulate it and get our new equation. No, then g of x would have to be 9x squared minus 3x plus 1. So recall, we're saying that if you have a function evaluated at this, you can factor out a number and you would get a new function, but evaluated at x minus 5. So these give you the same value. Again, f and g are different functions, but g is derived from f, right? And this works for any function. So let's try this out. Like, how would this work if I plug in x minus 5 into this? Might need some more space, so that'll be 9x minus 5 squared minus 3x minus 5 plus 1. Again, this is 3 squared, x minus 5 squared minus 3x plus 15 plus 1. You can bring that inside, so it's going to be 3x minus 5 squared plus negative 3x plus 15 plus 1. It's going to be 3x minus 15. Let's see. Minus 3x plus 15 plus 1. Right, these don't look identical. I mean, this part is okay, but you may be wondering, well, will this give us the same result as this one? You know, so that's going to be, let's see, 9x squared minus 45x minus 45x, and then plus 15 times 15. It's going to give, right, 15 squared. And here it's going to give us 9x squared, and it's going to be minus 45x minus 45x, and it's going to be plus 15 squared. So we do get the same identical part for this one. So It just threw me off a bit why it was negative here, but the sign switched, but it's fine. So either way, when you plug them back in, you get the same result. So to summarize, you can replace any function, right? So you have f of, I don't know, let's go with 2x plus 20. Then you can replace that function with another function. Just say that is equal to another function g, such that you can factor out the 2, so you get x plus 10. Right, and you can come up with your own concrete examples to see if that is true, but you can always make this substitution. Right, keep that in mind. It's going to be useful in a couple other examples when we start using auxiliary conditions. So again, as always, hope that helps.